Welcome everyone. In this video, I will discuss an important topic of quadratic equation, namely location of roots of quadratic equation. To discuss it, we need some basic definitions or ideas. For example, what is root? What is root? Root of a quadratic equation. We know a real number alpha is called root of fx if f alpha equals to 0. So we can find the meaning of roots of quadratic equation graphically also. What is graphical method? Suppose we draw graph of y equals to x plus 3. Now look, it cuts x-axis at minus 3, 0, y-axis at 0, 3. So this is y equals to x plus 3. So minus 3, 0. This is 0, 3. Now it cuts x-axis at minus 3, 0, minus 3, 0. Thus, we see from graph that x equals to, when x equals to minus 3, y equals to 0. So, graphically, roots of quadratic equation means the point of intersections of the curve and x-axis. Here, root is x equals to minus 3. Now, for a general curve, suppose this one, this is graph of y equals to fx. Now it cuts x-axis. Suppose this is alpha, this is beta, this is gamma. It cuts x-axis at alpha, beta, gamma. Therefore, alpha, beta, gamma are roots of the quadratic equation. So we need this idea. Then we need graph of parabola. Graph of parabola. So look, all of you know it. Now, y square equals to 4ax. So this is a parabola. Now, to draw parabola, we need many points, and joining them, we get a figure like that. So we are interested about the nature of it. This is y square equals to 4ax. Now look, x square equals to 4ay. So this is y-axis, x-axis, origin. So figure will be like that. X square, this is symmetric about y-axis. If 4a is positive, then the parabola opens upwards. Opens upwards. So we need this nature for quadratic equation. So x square equals to minus 4ay. Look, here a is obviously positive. Here a is also obviously positive. So if we draw this, we get a parabola like that. Symmetric about y-axis. This is O, this is x. So look, this parabola opens downwards. So we need idea of graph of these two types of parabola. Now general. So general quadratic equation. So y equals to, or fx equals to y equals to ax square plus bx plus c, a not equals to 0. So how to draw graph of this parabola? Now look, this is x variable is in terms of square and y in linear. We want to put it, look, in square form. So b by a plus c by a. Then a into x square, 2 into x, b by 2a, b square by 4a square, plus c by a minus b square by 4a square. So finally, a into x plus b by 2a whole square plus 4a square LCM, AC minus 4AC minus b square, or x plus b by 2a whole square equals to one by a, then bracket y, this is minus. So if we transfer this to left hand side, so this is plus. So x plus by, so this is b square, y 4ac minus b square by 4a by 4a. X plus by, so y by a, so this is 1 by a, so this is 4a. So b square, this. If we transfer this, so this will be plus b square, so plus b square. Or we can write this as b square minus 4ac. So this is parabola. Which type? X minus alpha whole square equals to 4 into a y minus beta. This is a parabola whose axis is x minus alpha equals to 0, that is parallel to y-axis. So figure will be like that. Look, vertex is alpha beta, so alpha beta, and axis is x equals to alpha. So this will be the nature if this is vertex. If 4a is, if a is greater than 0. So we need this idea. This is parabola, this one. Whose vertex is alpha beta. This is A. So these are the basic idea we need. So right. Now we consider d equals to b square minus 4ac. b square minus 4ac. d equals to this one. So this is called, discriminant. Now location of roots. Location of roots. Location of roots of fx equals to ax square plus bx plus c equals to 0. So number 1. So look, this is quadratic expression. So this is parabola. So look, we are getting many type of curve. So suppose parabola is like that. This type. It does not cut x-axis. It does not cut x-axis. Therefore, fx equals to 0 has no roots. So these are, look, so in this case, so look, no roots. No roots means roots are imaginary, that is d less than 0. So, and parabola is, look, opens are upwards. So for this figure, what we get? This type of figure, a greater than 0 and d less than 0. And look, fx greater than 0. fx greater than 0. This result to be remembered. So, if function is positive, then look, this is this parabola. This parabola, a greater than 0, open upwards, and d less than 0. It does not cut x-axis. So it is above it. So that is why fx equals to 0. This idea we need also for location of roots. Now we get this type of figure also. This one. Look, this is vertex of the parabola. Now look, for this type, what we are getting? A less than 0 because open downwards, and it does not cut x-axis. So d less than 0. So in this case, look, fx is always below x-axis. So fx less than 0. Fx less than 0. So these two results, value of fx, quadratic expression, value of quadratic equation fx is positive if a greater than 0, d less than 0. Clear from figure. And value of fx less than 0, look, does not cut it, so d less than 0 and a less than 0. Then we discuss this one, location of roots of fx equals to this. So there are several cases. So write case 1. Case 1. Both the roots are positive. Both the roots are positive. So roots are alpha, beta, and they are greater than 0. Both the roots are positive. So what will be our figure? So suppose this is origin. So both the roots are positive. So this is alpha, this is beta. So if a greater than 0, case 1, so we get a parabola like that. Look, this one, parabola like that. This one will be parabola like that. So this is f0, this is alpha, and this is beta. So from theoretical and for 2 a less than 0, what will be the figure? Look, this is origin, this is alpha, this is beta, and a less than 0, so this is downwards. So figure will be like that. A symmetric figure, parabola will be like that. So this is alpha, this is beta. Two roots, it starts x-axis at alpha and beta. So from theoretical view, so what is our condition? Both roots are positive. So sum is alpha plus beta greater than 0. Order alpha beta greater than 0. Discriminant greater than equals to. So this is our condition. Now look, from graphical point of view, this is f0. f0 is positive. f0 is positive. A is positive. So graphical condition. Graphical condition. So look, A into Fa, f0 greater than 0. A into f0 greater than 0. Look, for the second problem, this is A negative and A less than 0. So A into Fa greater than 0 for the both cases. Now this is vertex. Vertex, this is D. Vertex, this is D. This one is, suppose this is A. So what is vertex? Vertex, look, x minus alpha whole square equals to a into y minus beta. So vertex is a comma alpha comma beta. So for our parabola, so what is the vertex? What is the vertex? Minus b by 2a minus b by 2a minus, this is minus b by 2a, this is 0. So b by 2a greater than 0. So actually we have x minus b by 2a whole square. So this is x coordinate. This is x coordinate, then 1 by a. So x coordinate and this is y. We need y coordinate. This is y minus b square minus 4ac by what? I think this is given b square minus 4ac by 2a. So x, what is x? This one is x plus b by 2a whole square. So this is vertex, x coordinate of vertex. This one x. This coordinate is minus b by twice a. This is origin. This is minus b by 2a. Minus b by 2a greater than 0. Because look, this is origin and this is x coordinate. So b by 2a greater than 0. Here also this is minus b by 2a. This is also greater than 0. So this is our condition. So this is graphical condition and this is from our theoretical. So application. So write a problem. Let x square minus m minus 3 into x plus m equals to 0. Application. This is quadratic equation. Find m if both roots are positive. This case is very simple. Without graph you can say. So what is s? Alpha plus beta, sum of roots, equals to m minus 3 greater than 0. Therefore m greater than 3. 3 for product, alpha beta, m greater than 0. Then d, b square minus 4ac greater than equals to 0. If alpha beta is distinct, then only greater than 0. So a minus 3 whole square minus 4 into 1 into n greater than equals to 0. So m square minus 6m, so minus 10m plus 9 greater than equals to 0. So m minus 9, m minus 1 greater than equals to 0. And we know if it is linear inequations of greater than sign, then it lies, value of m lies outside the interval. That is this one. So what is m? m belongs to minus infinity to 1 union 9 comma. So now you have to take common region of these three. M greater than 3, m greater than 0 and this one. So what is the common region? So draw the figure. This is 9, this is 1 and this is suppose 3 and this is 1, this is 0. So m greater than 3. So figure will be like that. M greater than 0. Figure will be like that. And m greater than 9 to infinity. So this one. And less than minus 2. So what is the common part? Look, this part is not common. So what is the common part? This one. This is 1 and this is 1. This is one part. Greater than 3, greater than 0. So 9 to infinity is common part. So what is our problem? Find m. So answer is, what is answer? M belongs to 9 comma infinity. So first part m greater than 0. Second part m greater than 0. Third part is this one. So 9 to infinity. This is our common part. So roots are positive. Case 2. Both the roots are negative. Both the roots are negative. So both the roots are negative. So if we use theoretical method, then what we are getting? Sum s less than 0. Product greater than 0 and d greater than equals to 0. For two roots, now what will be our figure? Look, both the roots are negative. This is O. So negative roots. This is alpha. This is alpha. This is beta. So if a greater than 0, then parabola will be of what type? Open upwards. So vertex will be here. So we are getting figure like that. So this one. Or number 2, if a less than 0, so what will be our figure? This is alpha, this is beta, this is origin. So downwards. So this one cuts x-axis because, look, because it has two roots. So look, a greater than 0. This is a greater than 0. And this is f0. f0 is positive. So a into f0. Graphical condition. Graphical condition. A into f0 greater than 0. For this figure, look, this is negative. A also negative. So a into f0 greater than 0. So this is this one minus b by 2a minus b by 2a less than 0. Minus b by 2a less than, and in each case obviously b greater than 0. So write an application. In each case we always write d greater than equals to 0. So application. So write problem. X square minus a minus 3 into x. Same problem. Plus n equals to 0. So both roots are negative. So s equals to m plus 3 less than m minus 3 less than 0 implies m less than 3. P equals to product of root m greater than 0 and d greater than equals to 0. Same problem, so we have already calculated m minus 9 into m minus 1 greater than equals to 0. So m belongs to minus infinity comma 1 union 9 comma infinity. So now you look what is our common region. So look, this is 9, this is 3, this is 1, this is 0. So this case figure will be like that, touching 1 and 9 to infinity, this one. This is third case. M greater than 0. M greater than 0. Then m less than 3. M less than 3. So which one is common part? You look, this one and this one. This is first part. Then this. So common part is 0 to 1. I think, so what is the answer? M belongs to, answer, M belongs to 0, 1. 1 is included, 0 is not included. So this one. Location of roots. Both roots are negative. Now, case 3. One is negative and other is positive. Other is positive. Alpha less than 0, less than beta. So beta is positive, alpha is negative. So one root is positive, another is negative. So we cannot say what is S. S may be positive or negative. But here product is always negative. So P equals to alpha beta less than 0 and B greater than equals to 0. Now what is our graphical approach? Look, A greater than 0. So for A greater than 0, this is O, this is alpha, this is beta. A greater than 0, upwards. So suppose this one is vertex. So vertex of parabola, this. So this is A. This is A. So this is F0. This is F0. And for less than, second figure, number 2, A less than 0. So draw the figure. This is alpha, O, beta. Vertex downwards. So this one, this one. So this is vertex A. This is origin. So this is value of F0. So F0 into A. F0 into A is positive and this is negative. So what is graphical condition? Graphical condition. So A into F0 less than 0. This is F0 negative, A greater than 0. Now for the second case, F0 is positive, but A is this. And it is always this condition, B greater than equals to 0. So this one, this is our origin. Now application. So x square minus. So same problem, x square minus m minus 3 into x plus m equals to 0. X square, this. Find value of m for which both the roots of quadratic equations, one root is positive and another root is negative. So what is our condition? So look, A into F0 less than 0. What is A? A is 1. If we use graphical condition, A equals to 1. And what is F0? F0 is, so this is 0, F0 is M, I think F0 is M, F0 is M. So A into F0 less than 0, so M less than 0. We are getting M less than 0. So this is restriction on M using graphical condition. Next, number 4. So these first 3 are very simple. Next 4. This one 4. Alpha beta greater than K. Roots are, so in language, roots are greater than K. If both the roots are greater than a constant number K. So look, in this case, graphical method will be the easiest method. Because look, in this case you cannot write sum, it is positive or not, product, it is positive or not. So this is k, alpha beta greater than k. So here is alpha. This is suppose beta. So for a greater than 0, what will be the figure? So this one, so figure will be like that, and you get figure like that. So suppose this is alpha, this one is fk, this is vertex a. So this is for a greater than 0. For a less than 0, so look, same k, this is alpha, this is beta, so figure will be like that, parabolic arcs, this is a, now this one is fk, so this one is fk. So what is our condition? We look. Look, graphical condition. A into fk. This is fk and this is a. Both are greater than 0. So graphical condition a into fk greater than 0. For 2 also, look, k below x-axis. So this is negative and a less than 0. So this is a into fk. This is always greater than 0. Now this is minus by twice a. It is greater than k. So minus by twice a greater than k. Vertex is right to k. So minus by a greater than k. And obviously b greater than equals to 0. It is given or not? 2 roots. It cuts x-axis at 2 points. So this is common.